Joining us now on Notre Dame Day is Justin Crepp, a professor of astrophysics in the College of Science who develops new technologies and observational techniques to detect and study planets orbiting other stars. Back in 2013, Crepp was awarded a NASA Early Career Fellowship, and in 2017, he won the NSF Career Fellowship for his research at the Large Binocular Telescope. Justin was recently selected for the National Academy of Sciences Committee on Exoplanets. Justin, welcome to Notre Dame Day. Thank you for joining us. So to start, I don't know a lot about science, to be completely honest, but explain what is an exoplanet and why are they kind of important?
Right, it's a planet orbiting another star. Basically, we have 8 or 9 planets in our solar system that are all going around in the same direction, depending on whether or not you count Pluto. And there are many other stars out there. There's 400 billion just in our galaxy, so that's the Milky Way. And then there are trillions of galaxies. And so we're trying to find other worlds orbiting other stars because we think that's the most likely place where you could potentially develop life. And what we found so far is something like a fifth of all of those stars have planets around the same size as the Earth and around the same roughly approximate distance, in the sense that they might have a reasonable climate. And so, the goal of our research is to try to seek and search for life and to see if it might be similar to our own.
Wow, very interesting. Very quickly, do you consider Pluto a planet?
I do not.
Okay.
Sorry. It has a funny orbit and it doesn't really control what's going on out there gravitationally. It just happens to be the biggest ice ball that's beyond Neptune, is one way of thinking about it.
Okay, sure, fair enough. And well, I understand that you also design and build instruments for use with some of the largest telescopes that are out there in the world. Can you tell us a little bit about that?
Yeah, so Notre Dame has access to the Large Binocular Telescope and Keck Observatory. So that's Arizona, and also on the top of Mauna Kea in Hawaii. Those are some of the biggest telescopes in the world, certainly the biggest in the northern hemisphere. And you can think of a telescope kind of the first order as a light collecting bucket, but what you do with that light afterwards depends on the science that you're trying to accomplish. And so we divert the light to various instruments. We try to take images, we try to record spectra, we do various things to manipulate the light and really attempt measurements that have never before been made.
Wow, okay. And now you're also the director of the engineering and the design core facility. Can you just explain that a little bit, and how does that intersect with your work?
Right, so there's a group of professional engineers that we just hired and established this a few years ago. We service the entire College of Engineering, the entire College of Science, and all the departments within. If you're building a custom instrument, we can help you with the designs, with the procurement, with the testing, with the integration, with the delivery, whatever it is that a principal investigator doing world-class research needs. And so we have engineers that are mechanical, electrical, optical, systems engineering, control software, you name it, basically complex opto-electromechanical systems. We can build almost anything. Again, not just in astronomy, but to enable these measurements that have never before been attempted.
Wow. And now I'm going to ask you to predict the future a little bit here. But if you had to guess, what would you say is the next big thing in astrophysics that people should be on the lookout for?
So just last week, there was a very important mission that launched from Cape Canaveral, Florida. It was called TESS, the Transiting Exoplanet Survey Satellite. It's going to find Earth-like planets around stars that you can see at night, that you're going to know the address of all of the locations of worlds that could potentially hold life. And we're building instruments to make follow-up measurements to get the mass and the radius of the planet and figure out what it's made out of. You get the density, you can imagine, you can start to figure out, is that a water world? Is that a rock?
Sure.
Is it a big gas giant? And so we're trying to infer those properties around the closest stars and the closest planets in our solar neighborhood.
Wow, really quickly, do you think there's other life out there?
I do. I think it's inevitable. I think at least simple life, whether it's intelligent and how you define intelligent is another question, but I think there's just so many opportunities to roll the dice, if you were, with that many stars and that many exoplanets that I think it's just a matter of time. That's just my opinion, though.
Sure, sure, but a very, very well-educated opinion, and thank you so much for joining us on a Notre Dame Day. Certainly when you talk about the billions and trillions of stars out there, it makes you feel a little more small, but that's all right. Justin, thank you for joining us.